Okay, so today we're talking about factoring quadratics. I know last year in algebra you did quadratics, you may have forgotten it, but again, I'm going to assume that everybody has never seen this before and start from square one. Before we get into factoring quadratics, let's just talk about factoring general. What's the first thing you always do when trying to factor an expression? No, can't divide. We're not doing equations, we're doing expressions. Beautiful. Greatest common factor. Number one, GCF. And I'm going to put an exclamation point on that because people always forget that. And when you forget that, it makes your life very difficult. Okay. So for instance, example number one, we'll call it example A. 7x squared minus 21x. Okay. Now, before we do the example, let me talk about expressions versus equations. What's the difference? Tara.
Expressions don't.
Talk loud because there's that thing making all much noise.
Okay, so expressions don't have an equal sign.
Beautiful. And equations?
They do have.
They do, because equations have equal signs. Expressions don't. What do you do with an equation?
Solve.
And what do you do with an expression? Perfect. Okay, everybody got that? So when you're doing expressions, I don't want to see equal signs all of a sudden appear out of nowhere. And in fact, you should be monitoring. If I do it, then correct me, because sometimes I get caught up in the heat of the battle and I throw random equal signs in there. Okay, so what's the greatest common factor between those two terms?
7x.
Good. Are you familiar with the word or the term, right? What makes a term in a polynomial? How many terms in that polynomial? Two. What makes a term a term? It's a term. Yeah, good. Those are the things that are added or subtracted together. So one term is 7x squared, the other term is 21x. So Matt said the greatest common factor is 7x. If I take 7x out of 7x squared, Matt, what do I end up with?
You end up with x.
And then I take a 7x out of negative 21x, minus 3. Beautiful. Can I do anything else with that? No, so I'm done. Okay. Do not solve that. That's not an equation. Don't tell me that x is 0 and x equals 3. That comes later. Today we're just factoring. Okay? So step one, greatest common factor. Step two, we're going to be focusing on quadratics. So when you look at the quadratics, you want to look at step two. How many terms? Are there 2 terms, 3 terms, or 4 terms? We're going to skip 4 terms today, and we're going to focus on 2 and 3. We'll do 2 first. So subpart A, 2 terms. If they have 2 terms, and we're ignoring the fact that you've already factored out the GCF. Okay, so you've done step 1, you have a quadratic sitting there, you look at that quadratic, and that quadratic has 2 terms on it. The only thing you can do with that quadratic is you want to ask yourself, do I have perfect squares? Whoops, I overfilled it, sorry. So for instance, x squared minus 9. That's called the difference of perfect squares. Difference because it's subtraction, perfect squares because x squared is a perfect square, and 9 is a perfect square. That will factor. We'll come back to that in a second. X squared plus 9, the sum of perfect squares, doesn't factor. What's it called when it doesn't factor?
Unfactorable.
No? Well, yes. What's the technical? Yeah. You're so proud of yourself about that, aren't you? What's the other term? No?
Hangman.
Playing Hangman now?
Yay!
We love Hangman. We only
Okay.
have an A.
Tom, what do you got for me? Pick a letter.
This guy.
Pick a letter.
Oh.
You got 26 choices?
Okay, then T.
T. We're going old school. Head, body, 2 arms, 2 legs, dead. We
Okay.
don't put a hat and gloves and all that other crap. What do you got?
Oh, we're going again?
Yeah, keep going.
Nice. A.
A, as in aardvark?
As in avocado.
As in aardvark.
Yeah.
Good.
E.
E as in elephant?
Yeah. Oh, baby. There you go.
Yeah.
S.
S as in salamander. Good call.
You're gonna hang it.
I.
I as in iguana.
Yeah.
Ooh.
Oh yeah.
He's playing.
C.
As in cat.
Oh no.
Dos mas.
Did I already guess T?
You want to guess it again?
Did I guess S?
Yes, do you want this again?
Did I guess R?
You
No.
did not. Would you like to guess R?
Yeah.
Are you sure?
Rhino.
Let's do it.
You going with R? Okay.
Whoa.
Yeah.
Okay. Wow, this is really hard now. B.
This
Nah.
bad.
Have one change.
Yeah, what would the? I don't want to know what you're thinking.
I'm trying to think what could start.
I'm fearing for this man's life.
Right now.
He's hung with
We only have 35 minutes. F as in ferret. What would you guess F?
There's no F.
Why would you guess F? Such a random letter.
Aw.
He gone. Franny.
Is it prime?
It is prime,
I have no idea.
I had no idea.
which would be much easier to solve than if we were playing unfactorable on Hangman. Okay, so if it doesn't factor, it's prime. And the difference of the sum of perfect squares does not factor, ever. So you can ignore it. You see 2 terms, you have to have perfect squares. If they're not perfect squares, it doesn't factor and you move on. This is a special case when we get perfect squares and it's a difference. So then how does this factor? It's really simple. You take the square root of the first term. What's the square root of x squared? X. Minus the square root of the second term. 3. Times square root of the first term plus square root of the first. Done. Okay, factors nicely into 2 linear terms. I'm gonna leave this here because I overfilled it, yeah. So
Huh,
I
okay.
overfilled it, so once it gets a little cooler, you can sip some of it off the top without burning out your tongue.
Okay.
And then it's
Is that yours?
Okay, so we good? That's about the only time you're gonna see 2 terms, is when you're looking at something that is the difference of perfect squares. We can complicate it a little bit. We'll do example B here. By doing something like 16x squared minus 4y to the 4th. Okay, time to run with the big dogs. 2 terms. They're both perfect squares, so I'll save you the hassle of doing that. So now we need to factor it. What's the square root of the first term?
4x.
4x. Minus, what's the square root of the second term?
2y squared.
2y squared. Then you just repeat that with a plus sign. And we're good to go. Okay? Little bit of work with 2 terms. Most of the work, however, we're going to do is going to take place with 3 terms. And there's no trick for this. It's just a matter of getting comfortable with factoring. And some of you might already be comfortable with factoring. I'll call it cx squared minus x minus 6. We want to factor that button. If we factor it correctly, it will break into the same components we saw with the previous one. Two linear terms. And in fact, those linear terms are binomials. Binomial because there's two terms. Okay, multiplied together. So this is going to factor into something that looks like this. And I don't know what they showed you last year. They may have showed you this boxy thing or, yeah, I'm not going to do any of that. Question?
No.
Answer?
Yeah.
All right, hold on. Let me get there. I'm assuming, and I don't know if this is a bad assumption or not, that you can all FOIL. So you can do the opposite of this. Okay, good. Most people I find can FOIL just fine. It's going the other direction that's causing problems. So this is already multiplied out. Now I want to break it down into two components. So these first two terms, here and here, have to multiply together to give me x squared. What are the only two things that'll do that? X and x. No choice. It has to be that. The last two terms, here and here, have to multiply together to give me negative 6. I've got a couple options. What are they? Good and? Good and? No. Let's keep integer values. We don't want to get crazy. Oh, you're missing the easy one.
Negative 6 and 1. Negative 3 and 2.
She said that.
6 and 1.
6 and 1. Well, negative 6 and
Yeah.
1 and negative 1 and 6. So 4 possibilities. We have to figure out which one works. Now the catch is, let's just pick one. Let's try negative 6, and positive 1.
Negative 16.
Yeah, whatever that is. That's supposed to be a 6. My stylus got all wonky there.
Okay.
Looks good. Satisfies the first two numbers, x times x is x squared. Satisfies the last two numbers, negative 6 times 1 is negative 6. However, it doesn't satisfy the middle term. So how do I check the middle term? You check the middle term by taking this times this and adding it to that times that. X times 1 is x. Negative 6 times x is negative 6x. Negative 6x plus x is negative 5x, which is not what that is. So I made a mistake. Go back and fix it. That's why we have erasers. What should we try next?
Negative 3 and 2.
Negative 3 and 2. There's my x squared. There's my negative 6. Positive 2x, negative 3x gives me negative x. I'm good to go. We're done. It's fixed. Okay. For some reason, when people start doing the factoring, they then all of a sudden want to say, okay, now I'm going to multiply that out again. No. That's not what we're doing. We've already done that. That's what we started with. We want to factor it and then stop. Okay. Question?
You have to put a plus sign.
At what?
We got a plus
X
sign.
2. Forgot
Oh, yeah. Did I write it and it just didn't record it, or did I just forget
No,
to
you
write
just
it?
forgot it.
That's kind of important. Good catch. Okay. Is it starting to come back to you?
Yeah.
Yeah.
Good. So let me then just bombard you with a bunch of examples and see how you do on these. All right, let's try, This one's a little nasty because you've got what's called an A term. This is the A term. That's not 1. And you've got a big honking number at the back end that can be broken into a lot of possible factors. Write out your parentheses, try multiplying some numbers, see if you can get it to work out.
Thank you.
Let's start with the front end. What's the only way that you can get 3x squared?
Or don't you just put 3 on the outside of it?
No, everything goes in parentheses. What two numbers multiply together to give you 3x squared? 3x and x. The only possible way you can break that up. So that takes care of the front end. The back end in this problem gets pretty tricky because there's a whole bunch of ways to get 72. 36 times 2. 4 times 18. 9 times 8. Did I miss any? Okay. It becomes then a matter of guess and check as to which one works. And if it helps, write the factors of 72 over here. 1 and 72. And then I'll just do a plus or minus here because it's negative. It's going to be either one. Plus or minus 2 times 36. Plus or minus 4 times 18. Plus or minus 6 go in there too? 72 divided by 6? No. 12? Yeah.
Yes.
Confession, I never learned my 12 tables. I'm sorry. All right. And that's why 72 is such a pain in the butt, is because there are so many possible combinations. Tell me which one works.
Got 3 times 24.
Thank you very much. I was hoping you'd save me the hassle and just tell me which one works. Do you know which one works? You got it, man?
Yeah.
Beautiful.
-9 and +8.
Okay, -9 here,
Yeah.
-9 here, and +8. You sure?
No, flip.
Flip.
Wait.
Right. Okay, let's check.
Yeah. That's,
Yeah. There's my 3x squared, I'm happy. There's my -72. 8 times 3x, 24x. 24x minus 9x.
yeah.
Positive 15x. We're good. Okay? That's about as bad as it gets for us. Well, it'll get worse, but not for factoring. We'll start to see some 3 terms that don't factor at all.
I have
Question?
a question. Can't you take 3 out of the greatest common factor and have it like 3 and then like
Nice. I was hoping somebody. Is that what you were talking about before?
yeah.
Good. So, I purposely did it this way to show you this factors, and that's factored correctly, but you see how big of a pain in the butt it was working with 72. What did I forget to do?
I've dropped the 3.
GCF, take out the 3s. So I would have learned how to use my pen here. 3 times x squared plus 5x minus 24. Now we've got an easier thing to do. Okay, but I forgot to. I didn't do it. Okay, didn't follow my own rules. So am I done here? No, because now this still has a term to factor out. So I would have to take the 3 out of that one and get this as my final answer. So the GCF is going to make your life a lot easier because you can do an easy factoring on the front end versus a more difficult one further on. Okay. Let's do one more, and then we will be good to go. Try that one. Don't make the same mistake I made on the last problem. What do you need to do first?
Factor.
What do you need to do first?
Factors.
Yeah, I know factor. What kind of factor?
You should say.
GCF, correct. Notice that's not a quadratic, that's a cubic. And we haven't talked about factoring cubic, so you can reduce that cubic to a quadratic. By pointing out the right GCF. Okay, yes. Don't do that again.
Should start writing now.
Should be ready to go. See, I'm not messing with you. Try it again. Maybe I made a mistake. Turn the pen over so the points. There you go. Okay, now I'm just messing with you. I don't know what's going on.
Cool, that's the line too.
I'm not trying to mess with you. I thought it was ready to go.
Let's go blue.
Wow, that was weird. Okay, now you should be good to go. There's a little delay there.
2.
You gotta get your melon out of the way. Step to the other side because you're right-handed. No, other side, yeah.
How easy erasing this?
Over there, there's the little circle guy. No, that one. You gotta make sure you tap it though, not in the crinkle there. There you go. Then you gotta go back and hit the blue one again. You could use your notes if you want.
I remember it now.
You got it? There you go. Awesome. Let's give it up for Tommy. If nothing else, you need to recognize that you got to pull the x out of there. Otherwise, you're trying to factor a cubic, which we're not dealing with. We're factoring quadratics. So he also recognized that they all have a factor of 2. So pull out a 2x, and then he has to break down x squared plus 15x plus 36. So he's got his x squared there. On the back end, he's got his 36. Everything is plus because those are both plus. And then checking this, I've got 3x plus 12x gives me 15x. None of these will factor more because he pulled out the greatest common factor. So he's done. Okay, well done. That's all you got going on tonight is factoring. Again, don't introduce equal signs that aren't supposed to be there. These are just expressions. For those of you that are a little sketchy on factoring, you need to get going on this because we're going to be doing quite a bit of factoring for quadratics. Okay, we good? That would be day 1 in chapter 2.
We're gonna switch seats.
What time's the bell ring?
30.
30? No, I don't think so. I don't think we have time. We'll do it first thing tomorrow.
I don't think it's.
I heard my name.
I don't think it's up.
1 second. Let me stop recording.